So we continue with the notion of the curvature. I'm going to remind you that we define the curvature as the ratio between the magnitude of the cross product of r prime cross product r double prime, where r is the vector function divided by the magnitude of r prime cubed. Okay, so let's do an example, one more example. This is example 4 if I'm not mistaken, and this is from the final 2019 that says find the curvature at t is equal to 1 of r of t defined as t squared over 2 ln of t and t square root of 2. Okay, so basically we have to find how much is k of 1. Okay, the curvature evaluated for t is equal to 1. Now you will see I'm not going to, if the question is asked like this, find the curvature at a particular point, I don't need to simplify this expression for any general t. I can simply evaluate r prime, r double prime, then evaluate them at the given point, okay, and find the cross product and the magnitude. So you will see it's much easier to find the cross product of real vectors rather than the vectors defined in terms of t. Okay, so let's start from the beginning. First we find r prime of t. These derivatives are very simple. Derivative of t squared is 2t divided by 2 is just t. Derivative of ln of t is 1 over t. Derivative of t is 1, so just square root of 2. And then the second derivative of t is equal to derivative of t is 1. Derivative of t to the power of negative 1 is negative 1 over t squared. And derivative of square root of 2 is 0. Okay, now what I was saying, instead of finding the cross product between these two vectors, be careful, the question is not how much is the curvature at t, it's more specific, is how much is the curvature at 1. So why don't I simply evaluate how much is the derivative at 1, that gives me 1 square root of 2, right? I just, instead of t I put 1, so 1 over 1 is 1, and this is a constant, and the second derivative evaluated at 1 is 1 squared is 1 over 1 is 1 times negative 1, negative 1, 0. And now finding r prime cross product r double prime, is equal to, the first component is going to be 1 times 0 is 0 minus negative square root of 2, that's square root of 2. Then the second one is going to be 1 times 0 is 0 minus 1 times square root of 2, so minus square root of 2, and we multiply the second component by negative 1, so again square root of 2. And the last one is going to be 1 times negative 1, negative 1, minus 1 times 1 is 1, 1 minus 1 is negative 1 minus 1 is negative 2. Okay, now finding this, you see it's much easier. We don't have to work with the variable t, so the magnitude of r prime cross product r double prime is equal to square root of 2 squared plus square root of 2 squared plus negative 2 squared, which is equal to square root of 2 plus 4, which is square root of 8, which is 2 square root of 2. And then the only thing that I'm missing is finding how much is the magnitude of r prime. This is of course at 1, right? At 1, evaluated at 1. So r prime at 1, the derivative, how much is the magnitude of that vector, square root of r prime evaluated at 1 is 1, 1 square root of 2, so that's 1 squared plus 1 squared plus square root of 2 squared, which is square root of 4, which is 2. Okay, so finally we can come here. The curvature of 1 is equal to the magnitude of this cross product, which is 2 square root of 2, over the magnitude of r prime evaluated 1, which is 2 to the power of 3. And finally, that's equal to square root of 2 over 4. So be careful what is the question that you're being asked. It might save you quite a lot of time. Okay, the next thing that we're going to do, we're going to look at the special case of the curvature, and that's the case when we're talking about a function y is equal to f of x. So first of all, let me point out that that's a plane curve, right, in 2 dimension, and moreover y is explicitly defined in terms of x. So in case that curve is y is equal to f of x, we have a special formula for the curvature. The curvature is equal to absolute value of the second derivative of y over 1 plus y prime squared, the whole thing to power 3 over 2. Okay, so let's prove that if we are talking about a plane curve y is equal to f of x, that means that I can parameterize that curve as x f of x. The y component is f of x, and the z component is 0 because we are in the xy plane. Okay, then r prime is going to be 1 f prime of x 0, r double prime is going to be 0, f double prime of x 0. Then r prime cross product r double prime will give us 0, right? F prime times 0 is 0, f double prime times 0 is 0, 0 minus 0 is 0. The second component is 1 times 0 is 0, minus 0 times 0 is 0, and the third component is f double prime of x. Oops, sorry. Now the magnitude of this cross product is equal to square root of f double prime of x squared, which is the absolute value of f double prime of x, or just to be in accordance with our formula right there, absolute value of y double prime. And then all I have to do is figure out how much is the magnitude of r prime. It's square root of 1 plus f prime of x squared plus 0, right, which can be written as 1 plus y prime squared. From here, k is equal to r prime cross r double prime, the magnitude of that cross product, times the magnitude of r prime cubed. For a plane curve that can be defined as y is equal to x squared, we got that this is equal to absolute value of y double prime, right? That's the magnitude of this cross product, over the magnitude of r prime is square root of 1 plus y prime squared to the power of 3. And indeed we get this formula right here. Okay, so let's do an example. find the curvature of y is equal to sine of x at x is equal to 0 and x is equal to pi over 2. Okay, well, in a way we know what to expect, right? Because we know what is the graph of sine of x. That's pi over 2. That's pi. So we expect that the curvature at pi over 2 is going to be much bigger than the curvature at 0. So let's just make sure that that's the case. The curvature is equal to, I'm reminding you the definition, absolute value of f double prime over 1 plus f prime squared to the power of 3 over 2. Okay, or that's simply absolute value of y double prime over 1 plus y prime squared to power 3 over 2. Okay, this is easy. Y prime is equal to cosine of x. Y double prime is equal to negative sine of x, which means that the curvature is equal to the absolute value of sine of x over 1 plus cosine squared of x, the whole thing, to power 3 over 2. Okay, and now we have to evaluate this at 0 and pi over 2. So k of 0 is equal to sine of 0 is 0, and k of pi over 2 is equal to sine of pi over 2 over 1 plus cosine squared of pi over 2 to the power of 3 over 2, which is equal to 1. And as we expected, the curvature at 0, you see it here, the graph behaves like a straight line, right? And at pi over 2, it's obvious that the curvature is greater than the curvature at 0.